Okay, everyone, I think it's time we'll start now. Thank you for coming to our talk about SQL processing on Kubernetes and doing it easily. So my name's Andrew Stevenson. I'm the CTO of Landoop. My background is basically data, fast data, big data, doesn't care what it is. But I spent a lot of time in the financial markets, high frequency trading, so it's all about speed and doing things real time. And we have Antonios.
Hello there, my name is Antonios. I'm a co-founder and CEO of Landoop, and let's jump straight into the topic. So, from basic data containers like JSON or even XML, to even more modern data containers like Apache Avro, where we get a binary format, we get a data contract between our microservices or our data pipelines, we get type safety and pipeline safety, and we can even have data evolution. SQL makes sense. So it makes sense for three different reasons. First of all, we can query data, whether this is streaming real-time data or historical data. We can also easily build data integrations. Let's say I want to be moving messages, storing them into Elasticsearch, cherry-picking, selecting fields, defining the primary keys. It just makes sense. It also works for continuous streaming pipelines. We can perform data aggregations, we can be enhancing our data, and we can be building continuous unbounded queries with expressed via SQL. And when everything is stateless, it makes sense for us to have our entire streaming ETL in Kubernetes, have multiple pods for fault tolerance and resilience, and continuously operate data pipelines over Kubernetes. Again, when everything is a configuration, we can store it in GitHub, we can manage it, we can promote from environments, from development into UAT and into production. In the modern enterprise world, we have multiple data sources and multiple data sinks. And the idea of today's talk is how can we operate data pipelines via SQL and have a modern architecture. And what about my state? The state needs to be managed. And for that, we can use a distributed parallel file system like Apache Kafka, Pulsar, or NATS. So a bit of an introduction of who we are. We started back in 2016, introducing SQL layers into Apache Kafka in the open source with the Stream Reactor project that has almost 30 Kafka connectors. And we moved on with building Lenses, that is an industrial-grade set of tooling for building and operating data pipelines. I'm going to pass on the microphone to Andrew for the rest of the presentation.
Okay, so Antonios has talked a lot about why SQL is great, but we still actually need something to do the SQL processing. We're basically talking about data pipelines. We're talking about moving data around, doing manipulation, doing enrichment on data. A lot of people are running around and saying ETL's dead. It's not. We're just breaking it apart from a big monolith into smaller microservices. But what do we need for that? We need certain aspects. We need to get data in, we need to transform the data, and we need to potentially get the data out to our long-term stores. So getting the data in, so this is the Stream Reactor project that we started. So this is using Kafka Connect, which is one of the APIs from Apache Kafka that focuses on getting data in and out. We have 30 plus connectors. They're all open source. You know, we do welcome contributions. We also have the Dockers for them. There's Helm charts ready to go. But maybe what differentiates our connectors from some of the others out there is we have a SQL layer in it. This was the first SQL layer in Apache Kafka back in 2016. It's not a true SQL engine, this, but SQL-like. So what is it? It's Kafka Connect query language. So this is what we use in our connectors. So if imagine that you've got lots of different sources that have different characteristics, you may want to use the different features of those connectors. So in this case, we have Hazelcast, which is an in-memory grid. Hazelcast has different data structures. Maybe you want to write it into a ring. Maybe you want to write it into a reliable topic. So we allow you to write a simple SQL-like configuration to be able to target whatever you want, to be able to cherry-pick fields out and write it into the correct data store. So each different sink will have different grammar attached to it because they all have different things. Hazelcast is different to Influx, for example. What connectors do we have? Well, yeah, we have quite a lot. Where are they being used? So we have a Cassandra source that's being used by Walmart. They're actually contributing a lot on that. The sink is certified by DataStax. We have an Elasticsearch sink, so British Gas in the UK, Connected Homes, they do about 5 billion messages a day using our connector there. We also have connectors for Pulsar. Pulsar is very interesting, maybe better than Kafka. Performance-wise, it seems to be. We'll have to see. But the connectors in Kubernetes, what does it actually mean? What does it actually look like? Well, Kafka Connect has two different modes. It has a standalone mode, and it has a distributed mode. In the distributed mode, basically, you're starting JVM workers, so that translates into a pod. They all subscribe to a set of topics in Kafka, the backing topics. They subscribe with the same consumer group, so Kafka sees them as a consumer group, which is effectively your cluster. So in Kubernetes, we can simply deploy them as a deployment and have each replica as a pod as the actual worker. Once the workers are up, they basically listen to Kafka for all the actual work that they need to do, and then they'll spin up more consumers, for example, to write data out into Cassandra or Elasticsearch or whatever you want to do. So what's good? Well, Kubernetes ensures that our desired number of workers are there. And we can scale up and we can scale down the number of workers quite easily. And it was also very easy to deploy. The good thing about Kafka Connect, all the state is stored in Kafka. We've passed the book off to Kafka. It's taking care of the state, so if workers die and come back, it's going to reconstruct all its configuration from Kafka. What's not so good? Kafka rebalancing. I don't know if you're aware of how Kafka works, but you have consumer groups. If you join the group, Kafka rebalances the workload. But it means you stop processing while that rebalance is happening. If you leave the group, the same thing applies. Now, if you're outside Kubernetes on VMs and your VM dies, your work dies, it's not going to come back that fast. In Kubernetes, it will. So you'll get a rebalance, stop processing, when your pod dies, and then the pod gets restarted, you get another rebalance. So you're getting a lot of rebalances. That's something you want to avoid. So how can you avoid that? Your liveliness probes. Kafka Connect has a REST API to tell you what's happening with the state of your connectors inside there. So you can use the liveliness probe to say, do I want to make sure that I have my number of workers up and running? Or am I happy that something's going to fail and Kafka is going to rebalance onto the remaining tasks that are happening inside there? What you can also do in Kubernetes, because we can actually spin up connectors quite easily, is you can actually limit the number of connector instances in the cluster. So that limits the disruption on your Kafka Connect connectors running. Imagine you've got a cluster running and you've got 10 instances writing to Elasticsearch, writing to Apache Kudu. If you lose a pod, you're going to get a rebalance and it's going to affect all those connectors. So if you separate them out and have one connector per deployment, it's a lot easier and you limit the disruption. So that's Connect. This is the sexy bit. So we also have a SQL engine to do the transformation inside and on top of Kafka. So what you want to be able to do is you want to actually be able to join topics together. You want to be able to aggregate. You want to be able to count. So how do we do that? We use SQL. We go through the Apache Kafka optimizer. That maps down onto Kafka Streams. Kafka Streams is an API that's part of the Apache Kafka distribution. So we actually take our SQL, translate that into Scala code. It's an actual running then Kafka Streams application that lenses will then monitor and deploy for you. We do a bit more than that because we'll also actually let you subscribe with SQL for either historical data or continuous queries on the Kafka topics. So you can do that by a Golang if you want to. We have a Golang client. We have a Python client. Scala, we have a JDBC if you want to use JDBC. front end, JavaScript, React, Redux. So, a lot of trading systems might want to subscribe on FX currency rates on top of the Kafka with SQL. They can do that with lenses as well. Now, the nice thing about SQL is it's configuration. If I'm a data scientist, I might not know Scala, I might not know Java, I might not be familiar with actually building first my artifact, hosting the artifact, creating an image, creating a Helm chart, managing all that. Well, SQL is actually, it's just configuration. So imagine that you're a data scientist sitting in Jupyter, you're working away, you can actually hit lenses via the Python client we have, tell lenses to deploy a SQL processor for you, and then subscribe with a continuous query to get the SQL back out into your Jupyter notebook. So you can deploy and manage everything if you want to. I'm not saying you're going to do it. I'm not a data scientist. From Python in a notebook. Execution modes, how do we do it? We actually can run these SQL processes inside of lenses itself. Development only, really, you don't want that to be running in production. Or we can actually deploy and push it out into Kafka Connect. That is typically if you're not in Kubernetes. We have a lot of enterprise customers still, have their own data centers, etc. But more than likely, because you're at KubeCon, you're going to be deploying and pushing it out into Kubernetes. So we use the Fabricate API behind the scenes to deploy and monitor and watch what's happening, and also then collect the metrics out of the pods themselves. Again, what does it look like? Well, Kafka Streams is just a library. It's just a Java application. So we can say to Kubernetes, give me 3 instances of the same application with the same SQL, which is just configuration. We can pass in via environment variables, and Kafka will do the balancing of the load for us. Now, I have deployment and stateful set up there, because if you're joining and aggregating data, you have state. What Kafka Streams does is it actually uses RocksDB internally. RocksDB writes data to disk, and we also back that data into Kafka. So if you have a failure of one processing node of your Kafka Stream application, and it restarts on another machine, it can rebuild that state from Kafka. That's great, that's awesome. But what happens if your state is massive? What happens if you've got 40 gigabytes of state there? You could be building up a position report of messages coming through Kafka, and there could be 1 billion messages in there. It will recover, but it can take some time. It can bootstrap itself if it already sees that it has the RocksDB on the local disk. So if you use a stateful set, then you get this persistence following you around, so you get faster recovery times and faster boot ups again. So, this is the important bit. This is what it looks like. This is what we're deploying. This is a snippet from our Helm chart. It's nothing very fancy in here. We have an environment variable, and we push in the SQL. We have the pre-built Docker, which has the JMX exporter in it for Prometheus as well. And that's all we need to do. Obviously, there's a bit of magic going on with the Calcite optimizer in there. But basically what it gives us, it means that we can use Kubernetes to actually scale out and ensure our desired state. How many consumers do I want running? Also then we have metrics on there as well. We have consumer lag. We know what's going on with the processes, so we can then start building intelligence. You're moving into the realm of a lot more Kafka operators here at the application landscape. Do I need to scale up? Do I need to scale down based on what it's doing? Kafka's obviously handling the balancing of the data streams for us. That's awesome. And configuration as code. So we manage now 1 Docker, 1 Helm chart, and then we're just managing configuration that we can do and promote into production, just do merge requests into different environments, and we deploy our desired state into production, because if you're not getting into production, you're not making any money, and all your money, your business value is generated by doing the business logic, which is things like this. So state, yes, you will have state. So if you do have state, if you are aggregating, you are joining, use the stateful stats. So like I said, you can deploy via lenses. If you want to, you can deploy via Helm. That's fine. We'll see it. We'll monitor it. However, we don't know who deployed it. So if you go via lenses, we have an extra bit of security in there. We have role-based controls. We have access policies on Kafka itself. We have topic blacklisting, whitelisting as well. So we can not only stop you seeing the data, but we can stop you deploying a connector or a processor that's going to actually maybe take that data and write it somewhere else. Plus, you get all the other extra goodies that come with lenses as well, the WebSockets, the REST APIs, the clients. We have monitoring integration with Prometheus, alerts with alert managers as well. So at the end, what we get to is that we can build your entire data pipelines simply and easily using configuration, using SQL. We have lenses that's sitting on top, that's doing the monitoring, doing the deployment. We have a UI that we'll move to in a bit that allows a user experience on it. And we also have a lenses CLI as well. It's written in Golang, so we're probably going to be doing a lot more integration with Helm as well there, so we can actually say, deploy lenses, then deploy your application flow. Maybe you want some monitoring, maybe you want a Prometheus operator with it. Then we can give you the whole shebang. We don't deploy Kafka at the moment. Bring your own Kafka. There's lots of good distributions out there. And maybe we'll be supporting more than Kafka in the future. Apache Pulsar, nice piece of kit. So I'm going to move on to a quick demo. I'm going to ask Antonios maybe to help me here. Exit PowerPoint. So this is lenses. It's not on the screen. How do I get it on the screen? Yeah, now I can't see it. This is... So this is lenses, this is our main application. So what you're looking at here is the dashboard. You can actually see that we have a number of schemas here, we have a number of connectors running, we have a number of processes. This is actually what we're interested in. These are all the consumers that are happening on it. Audit trails, who did what. There's me practicing a few minutes ago. And these are alerts that are firing. So these are actually alerts will be coming out from Alert Manager if you want to. So this is quite difficult doing it this way, but bear with me. So this is the topic screen. So where you can see all the topics that are in the system, that the Kafka that we're monitoring, ingest rates, etc., configurations about all the different properties, what's the replication factor, the key types, whether it's Avro, whether it's JSON, etc. So we can drill into a topic, this one. So what you're seeing here is SQL fired directly on top of Kafka. So this is a live continuous queries coming out. We're sampling because we don't want to bring the browser down. We're going to kill the browser if there's too much data. We can then drill into the stream to see what the data is, so that we get a lot of use cases. For example, traders, risk managers who want to look at what's happening with the trading, different trades that are flowing through the system. We can also do it historically as well. So this is firing, show me the data from this point in time for this time range, if we want to. We have different views. We can flatten the data out. We can show you the raw. Basically, this is the raw JSON. Well, it's the Avro, but converted to JSON. It's coming through. Various different information about the topics themselves in Kafka, how many partitions, how it's been replicated across. Of course, there's alerting, everything on this as well. And who's consuming from this topic and what the processor lag is in there. So that's a metric that you'd want to scale. Maybe I want to scale automatically up because this process is too slow. Okay, Kubernetes, give me an extra runner. So I'm going to, obviously there's a lot in there. It's not a full-blown demo of lenses. But what I'm going to do is I'm going to create another processor. So this is actually pointing at one of our little mini cube instances, but it doesn't matter. I'm going to type. This is the tricky part. New. So I'm going to give it a name. KubeCon. Did I spell it right? Yeah. I'll type it. Could be. I don't want 15 actually. I'm going to deploy into Minikube. We could deploy into any cluster we want. This Lenses instance is actually sitting outside Kubernetes, but you can deploy it inside. If it's deployed inside, it's only going to deploy to that Kubernetes cluster, but we have some clients that, they have a lot of Kubernetes clusters. We can pick a namespace. So I'm just going to stick it in the default namespace, and I'm going to give it a pipeline. All this is going to do is just going to attach another label onto the pod, right, and then it's going to get collected in GMX metrics, so you can start asking questions of, okay, how do I promote this pipeline into production? What's the metrics of this pipeline? Imagine you're a data scientist and you're interested in just your flow. You want to be able to maybe tag your flow and be able to see how it's performing. So I'm going to do a copy paste into here. This is our SQL. So all I'm doing is selecting and filtering from the topic we were looking at before. So this is just going to say, okay, right, it's a simplistic example, but all it's doing is filtering out data where the speed's greater than 10. At the bottom there, we're setting the deserializer type for the key and the value, because in this case, it's avro. And we're actually going to say auto create the topic. So these are all properties that you can set on the consumers and the producers of Kafka itself. Now, you can do a lot more than this. You can join. Maybe if we've got time, we'll show an example of that in a bit. So if I click create, demo gods Wi-Fi permitting, we should have a new process. So there we can see that the pods are being spun up into Kubernetes. Yes, got lovely pod names. We have a topology that will come through. So this is the actual topology that's coming out of the Kafka Streams after it's gone through Apache Kafka. So we can then drill in to see what it's doing. For example, here, this is, we can make that prettier, but basically that's the filter that's happening. We have the raw data coming in. We're doing the select. And then we're pushing data out, so we should, yes, there it comes. So we have data that's coming out. So all these values on the other end, speed greater than 10. We can drill into the monitoring as well. So here we're seeing the lag on what's happening on across these five runners. And I can't see what that number is, but they've spun up and they've done 500,000 messages each since we started them. We can drill in a bit further. We get a bit more metrics on what it's consumed, what it's produced. And if we want to, let's scale it down. Well, actually, let's go for it. Let's give us some more. Now we're getting 10 more runners. So we've just deployed a SQL processor into Kubernetes, and that's it. And actually do that from Python, do it from Golang, whatever. Doesn't matter. There's a REST API for it. And what's also more interesting is if we've got the topology, right? Because we're deploying microservices. But I want to see my end-to-end flow. You deploy a microservice, you're deploying it actually as an end-to-end service. So we're deploying everything into Kubernetes. This also works outside Kubernetes as well. We know what you've deployed, we know the topology, we know how to stitch it together, so we can actually build the bigger picture. So if you think of things like GDPR, Kafka's not going to solve GDPR. No way. But you can start answering some of the questions. Where is my data going to? Because we have schemas as well. What data do I have? Where's it going? Who consumed it? It's not going to get rid of your data for you. The right to be forgotten is not quite going to work, but there you go. So here's our processor that we deployed. Again, it's the same information that you were seeing before. Metrics coming in. It catches up, so obviously the rate comes down. And that's it, really. One last bit before we go to questions is that we have our connectors, obviously, as well. So I want to do insert into Cassandra, so I can type my KSQL statement. Insert into This is difficult. Into this is not actually going to run because we don't have a Cassandra instance. Select star from topic A, something like that. Press deploy, and now you've written another piece of SQL. Configuration is code. SQL is configuration to deploy and write data out into Cassandra. It could be Elasticsearch. Doesn't matter. Spin up lots of them. Again, do it from whatever language you want because we have the client bindings. And I think that's it really. So, questions? Anybody got any questions? We are looking at the different connectors that are out there. I think Google do quite a good job on their PubSub one that they have, so we're not necessarily going to write that ourselves. There are some other ones that are a bit flaky in the open source world that we're taking over. We're doing a Hive connector, for example, for OC and Parquet support as well. A lot on the Azure side we'll be doing as well. Google PubSub, it seems to be doing a good job from what we see, so no immediate plans to do it at the moment. Yes, so we were asked actually, and we've got an open PR, so if you want to do a ClickHouse connector, then feel free. There's an open PR to do that. It has a JDBC driver for it, so there is a JDBC sync out there that we were actually commissioned to write a long time ago. It doesn't belong to us anymore. So you could just use that. Now, whether ClickHouse has a more performant API that you want to rewrite somewhere else, then maybe, I don't know. I don't know the details of ClickHouse. Well, a lot of people are. You can also export everything out from the UI as well. So what we're working on as well is more integration for creating a pull request, for example, in Lenses itself. But you can actually just export everything else out and put it into whatever versioning strategy you want to have. Some people, we've had clients who have a branch per environment, and then the data scientists or the traders may use Lenses as an actual just a playground. Then they'll export out the configuration, and then that goes into a version control and whatever process control the different people have to promote into production. But we are working on it because we want to be able to say, okay, there's this topology, this belongs to me. I want to take that topology and I want to promote that through to production. There's some tricky parts to tackle in there, secrets. So Kafka Connect, you have passwords all over the place for databases. They're actually just stored in Kafka. So if you can actually query Kafka, you can see passwords. We mask it. We do a bit of protection on there, but how do we handle that? Maybe fault integration. This is something that it's on our roadmap. Conceptually, they do the same thing. We're slightly different. We use Apache Kafka parser, so that's a bit more of an industry standard. For example, Spark, Flink, they use that. There is some technical details of why we're better. We think that, obviously, we're objective. We allow you to join on multiple fields. For example, joining value from the key onto a value from the value as well. We obviously deploy natively now into Kubernetes. Eventually, there'll be parity between the two. In the long run, we're not tied to Kafka. I've mentioned it before, there are other streaming technologies out there. Why not have the same SQL engine across everything? For example, there's no reason why we can't deploy Spark jobs. Spark have integration now with Kubernetes. We're not tied to Kafka. But conceptually, they do the same thing. We just think we've implemented it better. but we're objective. Any other questions? No? Okay. Thank you very much.